We've all been sold a very specific image of what intelligence looks like, a hyper-organized, frictionless state of mind, where complex problems are solved with robotic precision and lightning speed. But your day-to-day reality probably looks quite different. You might mumble to yourself, put off your most important work, and wonder if you're faking it. The truth is, high intelligence rarely operates smoothly. It functions as a chaotic, data-heavy cognitive engine. It requires unique fuel to run, and it produces highly unusual exhaust. Those daily habits you view as personal flaws are the exact biological mechanisms your brain uses to handle immense processing power. This diagram shows the brain's intake system. High IQ brains absorb a significantly larger volume of raw environmental data than the average human mind. Processing all this extra data helps you detect microscopic patterns faster. But it also means a ticking clock, someone's loud breathing, or a faint background hum can easily trigger an overload alert. The brain is attempting to process every minor input as critical data. This constant flood of information forces your working memory into strict prioritization. It explains why you might drop an everyday detail, like where you placed your car keys, but flawlessly recall a highly obscure fact from a documentary you watched 7 years ago. With so much data circulating, the system eventually requires a relief valve. When you find yourself talking through a problem out loud, you are engaging in external processing. You are coaching your own brain through complex reasoning to keep the working memory from bottlenecking. Albert Einstein relied heavily on this exact mechanism, routinely verbalizing his internal logic and requiring an assistant to capture the thoughts as he externalized them. Reacting intensely to minor noises or carrying on conversations with an empty room are the visible exhaust of a brain running at maximum sensory capacity. The engine's energy relies on the regulation system. This chart compares the release of dopamine for two different brains attempting the same repetitive routine. The brain with higher intelligence features a faster reward prediction system. It figures out the pattern instantly, meaning the dopamine payout plummets almost immediately. This rapid chemical depletion causes severe boredom and a desperate craving for novelty. This dopamine deficit triggers what psychologists call active procrastination. The brain refuses to engage with low-level busy work. It waits until a looming deadline raises the stakes, creating a high-pressure environment that finally provides enough chemical reward to execute the task. Because the daytime is filled with those low-reward routines, the engine conserves its energy. It prefers to hunt for creative insights late at night, when external demands and distractions finally fade away. Waiting until the last minute or staying awake until 3 a.m. is a highly calibrated dopamine engine, preserving its resources for challenges that actually require its full power. The final mechanical component is the analysis system, driven by a mechanism called metacognition, the specific psychological ability to examine and evaluate your own thinking. Look at how a simple past conversation maps out in a highly metacognitive mind. A single interaction instantly multiplies into dozens of different potential outcomes, alternate responses, and perceived mistakes. You might label this intense data analysis as social anxiety, but it is rigorous computation. This graph maps the emotional result of that computation, plotting confidence against actual competence. On the left side of the curve, a complete lack of knowledge generally produces absolute, unearned certainty. But watch what happens as actual intelligence increases. The confidence line takes a sharp dive. The more you learn, the more acutely aware you become of exactly how much you still do not know. Constant self-doubt and the persistent feeling that you aren't doing enough are often direct side effects of knowing exactly how much you still have to learn. Integrating these systems of intake, regulation, and analysis results in a machine that prioritizes depth over efficiency. This same neural sophistication makes the brain more attuned to subtle emotional cues. The heightened sensory processing that makes background noise distracting also amplifies empathy and emotional nuances that others might overlook. The defining historical indicator of this cognitive engine is an insatiable curiosity. It is a mind that demands continuous, lifelong learning, relentlessly asking questions long after the basic answers have been found. True intelligence rarely correlates with standardized test scores or flawless grades. It is measured by your situational awareness, your adaptability, and the depth of your thought. So the next time someone tells you that you are too sensitive, too easily distracted, or too lost in your own head, you simply don't need to correct them. You can just recognize it as confirmation that your brain is operating exactly as it was designed to.